Okay class, let's continue lecture. Alright. So we have done example for hold on and hold off. Okay. And then the other commands that are available, is available in MATLAB. We do have line to add additional graph lines to the existing plot. So let me try this example. We go to the software, the programming software. Alright. Let's take on the editing window. So we must put dot operators and then -26 times x plus 6. So this is the last thing. So you can see here, instead of using one line plot code, where we actually can use plot xy, xyd, and then xydd. Okay, previously in only one line, but instead instead of doing that, what we do here is we separated it into several lines of code, and then we use line. So this coding line will add the respective line, another line respectively. Right? So you need to have a different code. Okay, first line code for XYD, and then the second line code XYDD. So you type it separately. Okay, then we save and run. I put it civil default. Small case, I put it as ESMG. Okay, so change data. This is a graph. Okay, we should have legend G. Each line. Alright, so that is another way of plotting several lines in one graph. And then there is also function for semi-log. Okay, function for semi-log. Okay, semi-log y, where this function means is to plot y versus x with a log base 10 scale for y. So that means the data y will be log base 10, right? While semi-log x, it will plot graph of log x versus y, right? And while log xy, basically it plot y versus x with log base scale for both sectors. So for next chapter, okay, you're going to see how we apply function log and semi-log, right? And then there is also function error bar here, okay, where it will display a plot of its error bars. Okay? And there is a plot function for bar to plot bar, function to plot horizontal bar, function to plot a graph with stairs, and the shape of stairs. Okay, and this is to plot stem, this is to plot pie graph. And there is also a command function for plotting histogram, plot polar coordinate. This subplot is basically to plot to have several plots in one page, right? And then this figure command is basically to open additional figure windows. For fplot function, so for fplot function, basically it should come with round bracket, and then inside the enclosed round bracket you should write a function with the apostrophe and then the limits, and then followed by the formatting. Okay, coding. Alright, let's look here for this example where we're plotting this function. So you can simply type the functions inside the function plot, okay, inside the command plot, fplot, but you must put f in front it to indicate to the computer that actually you are plotting expression, where inside the coding you will insert the expression and then followed with the limit. Yeah, this is the limit, the normal limit of the graph. Right, then you can continue with another code for labeling of the x-axis and y-axis as usual. Okay, this is the graph when you plot. You can try by yourself. And this while example where you have several data, right? And from the data, you can have a sum of the experimental data, and you can calculate the error. Alright, so this is the representative of the error, right? And as an example, or a standard deviation. Normally we get the error from the average data or from the real data. So if you're from the average data, you can calculate the standard deviation, and then those standard deviation can be used as error data, right? Then we're using a function error bar here, plotting xy, and then y error. This is putting the error bar. So then what you get here, a line graph. The line graph is to represent xy response, x and y, while this I bar, the shape like I, is different height. This is to indicate the error size, error bar. So this is the graph, telling the graph of error bar. Then this code is for x level and y level. Alright, now let's look how about the three-dimensional. Okay, what is three-dimensional? What is different with three-dimensional? So basically for three-dimensional, okay, so there is a way of writing it, the code, okay. So and commonly people use 3D is because of the appearance, and sometimes some of the result will look good with the 3D appearance. Right? So what you need in the command, okay, basically the commands looks like this. This is from the basic syntax. So the plot you need to indicate by 3 at the back. So this computer will know that you are plotting 3D graph, and then you must provide 3 response here, 3 data, 3 vectors here, x, y, and z, and it must be the same size. And then followed with the formatting like specifier, property name, and property value, as usual. The same practice for the 2D plotting. Alright, so the procedure is for plotting function of the function for the form of z equal to fxy. So here x, y are the independent variable. So x, y is independent variable. Alright, and define the domain of the z. So z is dependent because z here is dependent on x, y. So the stage of creating a mesh and surface, what you need is first you create a grid in the xy plane. So must you create a grid in the xy plane. Then after that you calculate the value of z at each point of the grid. Then you can create a plot. So these 3 steps you must remember. Okay. So first we're creating a grid. What the coding needed? So we need to using a mesh grid to create a xy grid. So we define the output variable, which is x and y in capital, and there is a square bracket because this is matrix, right? And then assign to mesh grid, which round bracket, inside that the input is x and y. Okay, so capital X and Y is the metric of the x coordinate of the grid points, okay, where you grid. While x and y small case is basically a vector that divides the domain of x and y. Alright, now then after that we calculate the value of z at each point of the grid just now that we're creating. So by using the element by element calculation, and then we need to create a plot. So this we use a command function mesh and surf. Right? So the mesh made of lines that connect the point, while the surface plot, this surf is short for surface. It's areas within the mesh line where the area between the mesh line here is with colored. So that is what the surface do. Alright, let's look example. So you have this 3D surface plot. Alright, you are required to plot this 3D. So in the domain, this is the domain of the plotting. So first we define the x and y, and then here we do mesh grid. We'll be creating a grid for xy, Then after that,